So, Japan is releasing treated radioactive water from the Fukushima nuclear plant straight into the Pacific. And yeah, it's a plan that's causing a lot of outrage, a lot of fear around the world. But is that fear actually justified? Well, in this explainer, we're going to dig into the science, the history, and the really tough dilemma at the heart of this whole controversy. Right, so that's the big question, isn't it? Why on earth would they do this? And, the answer doesn't really start with science. It starts with a disaster that absolutely shook the world more than a decade ago. Okay, so let's set the scene. The date is March 11th, 2011. And what happened that day? Well, it wasn't just one disaster. It was three, one right after another, in this just catastrophic chain reaction. So first, you have this absolutely massive 9.1 magnitude undersea earthquake. We're talking about the most powerful quake in Japan's recorded history. It was what they call a megathrust quake, and it unleashed centuries of pent-up energy in just a few minutes. And all that energy had to go somewhere. It triggered a colossal tsunami. I mean, can you even imagine? A 50-foot wall of water just slams into the coast, and it completely overwhelmed the seawalls that were supposed to protect the Fukushima nuclear plant. They just stood no chance. The human cost, it's just staggering. Nearly 20,000 people gone. It was the deadliest single day for Japan since the atomic bombing of Hiroshima. Just think about that for a second. So, back at the plant, the power is out. All of it. The tsunami knocked out the backup generators. And without power to the cooling systems, the nuclear fuel starts to overheat fast. This creates a huge buildup of hydrogen gas and boom, a series of massive explosions, which led to not one, not two, but three full reactor meltdowns. These meltdowns created something called corium. It's this lava-like mixture of molten nuclear fuel and metal, and it is one of the most hazardous substances on the planet. It got so hot, it literally melted right through the thick steel reactor vessels. And to this day, we still don't know exactly where all of it is. Now, you're probably thinking about Chernobyl, right? And it's a fair comparison. Both were level 7 disasters. That's the worst you can get. But here's where things get really different. At Chernobyl, the reactor itself exploded, sending radiation everywhere and leading to an estimated 4,000 plus deaths. At Fukushima, the meltdowns were actually contained. It released way less radiation, and here's the key part. There were 0 direct deaths from that radiation. That is a huge, huge difference. But the physical destruction is only part of the story. The disaster left this incredibly deep cultural trauma. The loss of life was so sudden, so total, that people started reporting seeing ghosts of those who died in the tsunami. Phantom figures waiting for a bus that would never come, or apparitions in puddles. It's a haunting testament to a kind of grief that's just too big to process. And it's that profound trauma, that history of loss, that serves as the backdrop for the whole dilemma Japan is facing today. See, the crisis didn't just end when the reactors were stabilized. Oh no, it just changed shape. It became a problem of water. So to stop another meltdown from happening, they have to constantly pump water over those hot reactor cores to keep them cool. The problem is that water, plus groundwater that's seeping in, it touches that molten fuel, that corium, and every single day it becomes highly, highly contaminated. So what do you do with all this contaminated water? For more than a decade, they've been storing it in these massive tanks, but they're literally running out of room. So they came up with this multi-decade plan. The idea is to treat the water, dilute it with a ton of seawater, and then slowly, very slowly, release it into the ocean over the next 30 or 40 years. Now they have this amazing cleaning process called ALPS. It can remove pretty much every dangerous radioactive element from the water. But there's a catch. There's one thing it can't get out: tritium. And that's because tritium is a radioactive version of hydrogen, so it literally becomes part of the water molecule itself. It's like trying to filter the wet out of water. You just can't do it. And this is where we get to the absolute core of the debate. On one side, you have the science. The plan is to dilute the water so much that the tritium level is 40 times lower than Japan's own safety standard. The total amount of tritium they'll add is less than 3 grams, compared to the 8,000 grams that are already in the Pacific naturally. But on the other side, you have this deep, deep public distrust. And that distrust? It didn't just come out of nowhere.
An independent investigation found that TEPCO, the company that runs the plant, had failed to meet even basic safety requirements. They got warning after warning for years from the US, from their own government, even from their own internal reports about the exact things that went wrong. And they just didn't act.
All right, so let's zoom out a bit. Because what happened at Fukushima and what's happening now with the water, it really forces us to look at the bigger picture. The huge paradox at the very heart of nuclear energy. On the one hand, nuclear power is, without a doubt, one of the cleanest energy sources we have. Look at the CO2 emissions. For every kilowatt hour of electricity, nuclear puts out just 12 grams. Cool? A whopping 820 grams. So yeah, it's a pretty powerful weapon in the fight against climate change. But then you have the other hand. The cost when things go wrong is, well, it's astronomical. The cleanup bill for Fukushima is estimated to be over $500 billion. To put that in perspective, that's like 10% of Japan's entire economy for a year. The financial risk is almost as scary as the environmental one. But you know, maybe the biggest, thorniest problem with nuclear power isn't even the risk of a meltdown. It's the one thing we still have absolutely no good answer for. What on earth do we do with the waste? So these used fuel rods, right? After a few years, they're spent, they can't make power efficiently anymore, but they are so far from being harmless. They stay lethally radioactive for tens, even hundreds of thousands of years. That's a timescale longer than modern human civilization has even been around. So where do we put this stuff that stays toxic forever? Well, the answer is kind of shocking. Right now, every single bit of high-level nuclear waste on Earth is in temporary storage. Most of it is just sitting in cooling pools right at the power plants, waiting for a permanent solution that we still haven't figured out. And this leads to a challenge that's almost philosophical. Let's say we do build a permanent tomb for this waste. How do you create a warning sign that lasts for 100,000 years? How do you make sure it's understood by any culture, or maybe not even a human one that might stumble upon it long after our languages and symbols are dust? Believe it or not, the US government actually commissioned a study to figure this out, and their proposal was intense. They suggested creating a message that wasn't meant to inform, but to repel. The whole idea was to create this universal feeling of dread, to basically scream across time, "This is not a place of honor. Nothing good is here. What's here is dangerous and it will chill you." Which, at the end of the day, leaves us with the ultimate question, doesn't it? Is nuclear energy a clean bridge to the future, or is it a toxic legacy we just can't manage? When you weigh the incredible benefits against these forever risks, you have to ask yourself, what is the true price of power?